In this video we will see how to delineate watershed from digital elevation models in R. So we need these four libraries: the 3D Verse, raster, SF and whitebox. So main library is whitebox. So if you are using this library whitebox for the first time, you need to install the toolbox of whitebox also. So for that you have to run this syntax. This is only one time. Next time we don't need. So now we will initiate this toolbox using function whitebox tool initiate. Run it, and now this is our working directory, and then we will read our digital elevation model using function raster and then plot it. So this is my DEM. For generating watershed from digital elevation model in R, we need bridged DEM. So this is the function whitebox tool underscore bridge underscore depressions underscore list underscore cost, and then DEM we need. So this is the DEM we have read, and then output you have to write. So I am writing it as a bridge, and distance 5 means pixels, number of pixels, and then fill is equal to true. So you will run it and then plot it. So this is the bridge DEM. Now from that bridge DEM we will be calculating flow accumulation. So the function is this one, wbt underscore d8 underscore flow accumulation, and d8 is deterministic 8. That is the method of generating flow accumulation. Already we have seen in Saga. Run, and then we can now read this raster as FA and plot it. So this is the flow accumulation. You can zoom it. So it may be not visible, it is grayish color you can see here. Now flow direction. So in R it is called pointer. So again the function is wbt underscore d8 underscore pointer, and DEM we will be taking bridge DEM, and then output as a pointer. Run it, then we can read this pointer and plot it. So this is the flow direction raster. Now we will extract the streams from the flow accumulation. Here we need to give the threshold of flow accumulation, that if the flow accumulation is more than 5000, then it will be considered as a stream. So you can try on getting more or less. So I am giving here 5000. So run it, and this is the function for that, wbt underscore extract underscore streams. Then we can read this raster and plot it. So if you are zooming it, you will see actually it is in yellow color, so not visible. Then now we have to create a pour point from the location. So you can generate it using a KML file in your area. So these are the 4 points I have created that I need here, here, here and here. So these are the 4 points I need watersheds. So this lat long of these 4 points you can get from here, and those you can write here. So now we will create a tribal of, means create a pour point using this latitude longitude. So we will be using function tribal, and we have to assign as long and lat, long and lat. So long and lat. So all the, if you are having more than this, you can also arrange like this only. So we will run it, and then we will convert this 4 point to spatial points using function spatial points, and you have to provide the projection. So run it. Now we can write our 4 points, these 4 points as 4 point dot shape, and we can plot also. So these are the 4 points. Now since you cannot get a GPS coordinate or coordinates from even Google Earth exactly falling on the streams what you have generated from DEM. So in that case, another function is there, that snap 4 points. So you can define the snapping distance. So this distance is, you have to be careful here that since your DEM is in GCS, so that unit should also be in GCS only. So you can see here your DEM is having 0.00026 resolution, so cell size. So we are here giving, suppose 0.0005 means 1.5 cell size distance will be there, means suppose it is maybe 40 to 50 meter snapping distance we are giving. So we will be using 4 points streams, that stream raster we have created here, and then output we are giving snap, and this is the distance already I have discussed. So we will run it. Now we will be using this snap point as a 4 point now, and then this is the stream. Now you can plot the stream and the 4 point on it. This is the output. Now we will delineate the watershed. So the function is wbt underscore watershed, and this is pointer. It needs the pointer file, means direction, then 4 points. So our new 4 point is this snap, then output is watershed.tif. So we will run it. Now we can read this watersheds tip file and then plot it. So you will see only two, actually you will see one gray and one green. Since we have given 4 points, so we expect that there should be 4 watersheds, but as I told, there is the points are not falling on the stream, then it will give a single cell watershed. That we will see here. See, we will convert this raster to shapefile first using ST and then plot. See, 1 and 2 is there, others are not there. Others are there, what we see here, 1 and 2 small. You can see here small slivers are there. These are the 4 points which are not falling on the streams. So you can see here again, we can filter the first one and then plot it, then second one and plot it. So see, the second is only 1 pixel. Similarly the third one is also a single pixel, and then fourth one is, means the 4 point of 4 and first are falling on the streams, so you are getting a watershed. Otherwise you will get a single cell slivers. So now we can retry using increasing the snap distance. So we are increasing the snap distance to 2 pixels. So we will be creating a new snap, that is snap 2, and then we will be using it as a 4 point. Now we will again go for developing a watershed, that is watershed 2, and then run it and plot. Now you can see 4 watersheds are there. So now we can convert them to shape files, and then see here you will see that the first one, this blue one, should be inside this purple one, but since you have already given a 4 point here, this shape it is not covering this portion. So similarly for this 4 point, it should be the entire watershed. Actually the one river is flowing in between like this. Here you can see here, so this river, so the first one is here, it is creating one watershed here. The second one, for the second one, it should be entire region like this, and for third one also it should be like this, but it is getting separated. and for fourth already it is outside this main river, so it is getting only the small one. So better option is, we will see first here. So I am plotting this, and then this is second one. So you see, it has not included the first one. Similarly, the third one is not including the others. So the better option is, this is the fourth one. Now, so better option is, you just get your stream network and then the snap 2. This is the snapped one. Now you see, go here and see whether it is falling on your stream or not. So this one is the first one, it is falling on the stream, so this is not a problem. Then go to second one, see, it's falling on this, so the bigger net river, so it will be creating a, so it is creating a watershed like this, bigger one. Similarly, the third one is getting here on the same river, so it will be creating a bigger watershed. So to avoid it, if you want only a smaller one, then just in the same area, just create a new one. So I have created here, this I have not changed, but this we have to change from here to here. Similarly, from here to here, and from here there is no change. So since only 2 we have to change, so we have now created a 4 point corrected. So we will read directly, generate watershed with the 4 point corrected, and then plot it. Now you can see the 4 watersheds. So we will convert to raster, convert to shape file, and then plot it. Now you can see all the 4 watersheds here. Now we can save them. Then similarly, now you can, if you want to filter each watershed as separate shape file, that also we can do here. We will filter it first. We will filter as watershed 1, and then write it. Then similarly for 2, 3 and 4. So now you can see here, this is the whole watershed, 1, 2, 3, 4, and separate files here. So this is how we can delineate watersheds in R from digital elevation models. Thank you for watching.